Pure Mathematics 1, Coordinate Geometry. Let me take you to the note. Right. So write the topic. So I've just written Pure Mathematics 1 again. On top, you don't have to do it. Your book is Pure Mathematics 1 book, I'm sure. So it's written right on the first page, I'm sure. So on a new page, the second topic, Coordinate Geometry. Write the topic. And please have your color pens, highlighters, all your fancy stuff around. Take them, get them ready, because this note needs a lot of decoration. Okay. And let me ask you, have you heard of this term before? Coordinate geometry. Now I know that you have heard of geometry. You have learned geometry, things in geometry. You also have learned the word maybe coordinate system. You know what coordinates are, pairs of coordinates of a point. So the word coordinate you have seen in other contexts in mathematics. But have you seen these two words together as a topic? Coordinate geometry. Have you heard of this before? Now you have to communicate with me either by writing in the chat box or just by talking to me. Have you heard of this phrase, coordinate geometry, before? If it's no, it's just a matter of dropping a no on the chat box. Okay, send it to has, right? You have heard of this in school. Others, where in school, send it to in your O-levels, did you come across this word? So you have learned about coordinate geometry, is that right? In advanced level. You have started this in school. Okay. Right, so before that you had not heard of this term, right? So it is for the first time in advanced level you are hearing this word, is that right? Okay, so I will throw this question at you, okay? What is coordinate geometry? What do you think it is all about? You have to talk now. I mean, I don't think typing would do. What is this section all about? It's about graphs, okay? Yeah, that's a good answer, Umasha. Anyone else? But then why do we not call this graphs, this topic? Why this fancy term, coordinate geometry? Where does it come from? Why are we connecting these two words, coordinate and geometry? Because if you think about it, what is geometry all about? Geometry is all about shapes in space, right? Two-dimensional objects, three-dimensional objects in space. If you think of all the two-dimensional objects that you have learned, circle, triangle, square, rectangle, trapezium, and all these two-dimensional shapes in 2D, and three-dimensional objects in 3D, sphere, prism, cylinder, cone, and things like that. That you learn about shapes in space. It's a spatial thing. What you learn in geometry is something to do with things in space. It's about shapes, right? And the word coordinate comes from that comes from graphs. You have seen the coordinates. We talk about coordinates when you draw a graph. So what is this connection between graphs and shapes, right? Why are we bringing these two together? So I will give you more insight to that in a little bit. copy these 5 subtopics. So in the introduction, I will tell you what coordinate geometry is all about. So we will be going through a little intro for the topic. Then we start with the atom in the geometry world. The atom in the geometry world is the point. Everything is made up of points. You collect points and make a line. You collect lines and make a 2D shape. Then lines collect to a plane, and then planes, by connecting planes, you can make other 3-dimensional objects. So if you go down to the first atomic object in geometry, it's the point. So we learn about points, and then lines, and then curves, and there are subtopics that are coming under this. These are the main topics, right? And then finally, intersection of these different shapes, curves and curves, lines and lines, curves and lines, and all that, right? So this is actually this whole topic is an intro for this big topic in math called coordinate geometry. Tell me let me know when you're done. Drop a message saying done. Okay, copy the 5 subtopics. Okay, Umasha says done. Today my document reader doesn't look. It's all blur today. I don't know why. I might have to use the Zoom whiteboard instead of the document reader today. Okay, so you're done. So for the first topic, 2.1, introduction. Introduction. Okay. So if you look at the history of mathematics, or if you just think of from your existing knowledge, if you think about, I'm going to bring up 2 separate topics in mathematics, and I want you to think about these 2 topics in math. Okay, the first is geometry, because you're very familiar with the area in mathematics that is called geometry. You know what geometry is all about. What you learn in geometry, as I said, you learn about things in space, objects in space, 2-dimensional and 3-dimensional objects. So take a few seconds and really go into the world of geometry. Okay, it's all about objects in space, triangles, rectangles, and then these shapes, 3-dimensional shapes, and all that, right? Just stay in that world for a few seconds, and you learn how to find the perimeter, area, volume, these things, right? That's what happens in the world of geometry, right? Now take your mind into the world of algebra. Do you feel the difference between geometry and algebra? Okay, now you go into the world of algebra. In algebra, what do we learn about? In the world of algebra, it's all about these expressions with unknowns and variables. You work with equations, you solve equations, formulas, inequalities, right? It's all about algebraic expressions and having equations with these unknowns and solving them, all these algebraic work that you do, right? Do you feel the difference between the world of geometry and the world of algebra, right? what coordinate geometry, this area in mathematics called coordinate geometry, was formed when mathematicians saw that these seemingly very separate, nothing to do with each other areas in math, algebra and geometry, actually does have a huge connection. Coordinate geometry was the name given to the area in mathematics that combines or brings these two separate areas in math together. Okay, the biggest insight that you should get out of this topic is everything you do in algebra, think of any simple thing that you do in algebra, like something as simple as solving a simple equation. That algebraic process, now you think of solving an equation, right? You make x the subject, you minus something from both sides, you bring this term to that side, you do all these algebraic manipulations and you solve an equation to find x. That algebraic process has a geometric meaning. You can look at it visually. Solving an equation can be interpreted as something that happens with shapes. Okay, every time you solve an equation, something geometrical is happening underneath. You have some sense of it already because we saw a little bit of that in quadratics. So this connection that was made between two separate, until coordinate geometry was discovered, these two areas in math were treated as two separate, no connection, two separate areas. But then coordinate geometry brought it together, and then in coordinate geometry, it's kind of, we are learning about geometry. We learn about lines and curves and these things in terms of equations, right? So it's algebra and shapes studied together. And all of that happens because of a trick that we do. We place all our shapes in a coordinate system. That's where the word coordinate comes from. For example, now if you think of a line, if I draw a line on a just plain sheet of paper like this, let me just draw that right now, okay? In geometry, you have say I draw a line in space. It's just a line, right? I mean, there is no significance. I put a point somewhere. It's difficult to put a point. Say that's a point. You know, a point has, how many dimensions does a point have? A point. No dimension, zero. Okay, it's just a point. No length, no width, no height, nothing. It's just one point. It's no dimension. A line is one dimension. A plane is two dimension, and so on. Anyway, if you don't get it, it's okay, right? Now, if I keep a point in just in blank space, now this is I'm keeping the point. I'm drawing the line on a paper, two-dimensional paper. Or imagine having a line in space, or having a point in space. It has no significance, right? Just a point lying in space. But if I place this point or the line in the background of a coordinate system, now you are already familiar with these coordinate. You know what the meaning of a coordinate system. This x and y coordinate system. The moment you place that, you have a reference. You can say exactly where your point is. It's at this position. It's at this location. Without a reference, if something is just lying in space, think about outer space. If you're just floating in outer space, no one can say where you are until there is a reference. If there is a planet nearby, you can say, oh, I'm this much further from that planet and north to the other planet. I mean, if you don't have any references, you can't say where you are, your location. So this coordinate system provides a reference, and then once that is placed, once you look at these lines and points with respect to or relative to this coordinate system, they suddenly have a whole new meaning. This point has a like an address. I can say it is at 1, 2, 3, 4, 5, comma, looks like 5, comma 3. I can say exactly where it is. Now it has an identity. It was nobody before. Now it is somebody. It's the exact 5.5, comma 3 point, right? And even the line now suddenly has an identity. It's not just a line. I can say it's y equals, looks like 1, 2, 3, like maybe if that is exactly 4, some 3x, I don't know, I have to compute it, plus 4, something like that, right? So this is what we do in coordinate geometry. Geometrical objects like points, lines, and curves, we give them algebraic identities. Isn't this an equation, right? Doesn't that come from algebra? But the line is a geometrical object. So in coordinate geometry, this is what we do, right? And then everything that we do in algebra turns out to have a meaning geometrically or visually, and it is this beautiful area in mathematics, because you get the algebraic flavor and also the visual flavor of things, okay, together. It's like when you have vanilla and chocolate ice cream together, it tastes like it's more delicious, right, than just having vanilla ice cream or the chocolate ice cream. It's like that. Okay, so here's what I just explained. You copy up to this. Okay, use different colors as I have. So I use one color for the word geometry and another color for the word algebra. And then coordinate geometry is what connects these two, what tells you how these two are connected. Now, if you have any questions, you have to ask, okay? So if I slowly read, in geometry, we study about shapes in space. Within brackets, 2D and 3D. 2D means 2-dimension and 3-dimension. 2-dimensional shapes and 3-dimensional shapes. Full stop. In algebra, we study about expressions, equations, and inequalities. In algebra, we study about expressions, equations, and inequalities of unknowns and variables that are represented with letters. New paragraph. Coordinate geometry. So you have to write the word coordinate in the color you wrote algebra, because that's where the algebra connection comes, and geometry in the color you wrote geometry in. Coordinate geometry brings these two seemingly unrelated branches of mathematics. Coordinate geometry brings these two seemingly unrelated branches of mathematics together. In coordinate geometry, we represent geometrical shapes. We represent geometrical shapes within brackets, points, lines, curves, close bracket. In coordinate geometry, we represent geometrical shapes within brackets, points, lines, curves, close bracket, using numbers and equations. Using numbers and equations. This is made possible by placing these shapes, in a grid called the Cartesian coordinate system. This is made possible by placing these shapes in a grid called the Cartesian coordinate system. For your knowledge, the word Cartesian comes from the name of the mathematician who did this first. His name is, does anyone know the name of the mathematician behind all of this? Does anyone know? His name is Rene Descartes. Rene Descartes. If I write that, I am not sure of the spellings, but it looks like this. That's how his name is. It's like Descartes, but it's Descartes. Descartes. Rene Descartes is the name of the mathematician. And to honor him, this coordinate system was called Cartesian. From Descartes, we took the part Cart and say we call it Cartesian coordinate system. Right? And this new way of looking at geometrical shapes, lets us calculate various information about these shapes, numerically and via algebraic equations. Numerically and via algebraic equations. New paragraph. The greatest insight you will have in this topic is that solving any equation, set of equations, inequality, any of these, okay? The greatest insight you will have in this topic is that solving any equation, set of equations, like simultaneous equations, right? Inequality has a geometric interpretation. has a geometric interpretation. And at next line, now in your level, we are only looking at two-dimensional coordinate geometry, okay? So you write, we will look at two-dimensional coordinate geometry, that is things on a plane. That is things on a plane. And let me tell you another thing. This coordinate geometry is sometimes called analytical geometry. So if you see that word somewhere, you have to know, oh, it's the same thing, okay? Coordinate geometry or analytical geometry. Analytical means you analyze geometrical objects using algebra, like analytically. So that using equations, using numbers. It's just a shape, it's something that you draw, right? But you study about it using equations or numbers, and you assign these things with numbers and equations. And by working with the equations, you are working with the object. So it's also called analytical geometry. Just keep that in mind. If you want, you can write that, maybe right on top where you wrote coordinate geometry / analytical geometry, the same thing. Right, so all these things happen that we talked about because of this Cartesian coordinate system, right? So when you want to study about a line, you place a coordinate system behind it in the background. Then your line suddenly becomes something like, you can talk about certain features of the line. You can talk about the slantness of the lines. You can give it a number. You call it the gradient, right? If you didn't have a coordinate system, if you didn't have any numbers or nothing like that, if you just had a line, if I ask you how slant is it, the only way in which you can say that to me is it's about this much. I mean, there is no, how can you express that, right? How slant it is. But if you have a coordinate system, you can exactly give a, it's slanted so that its slope is 3. That means if you go from the line, if you go 1 unit this way, you have to go 3 units up. That gives you a sense of the slantness of the line. So this having a coordinate system in the background of these shapes gives you a whole new, I don't want to use the word dimension because that already has a meaning in geometry, but it gives you another level in which to talk about these things, right? So first we'll see what this Cartesian, you already know these things. This is just to make your note complete. I'm giving you this, okay? So Cartesian coordinate system is, what we do is we take like one real number line and place another real number line perpendicular to it. We call them the x-axis and y-axis. When you do that, it creates a grid, and that grid makes it possible for you to say the location of any point on this plane. It makes things very easy to work with. Without it, it's when you just have empty space. If I show you a point, you don't know where it is. But with the coordinate system, it provides like it's like, like on the earth, we have longitude, what do you call them? I forgot the 2 words. What are the 2 words? I forgot it. Not altitude. Altitude is from what, the height. Latitude and longitude, right? Latitude and longitude. Latitude and longitude. And that's how we say where something is. So that's the coordinate system. Thank you both, Senitu and Lishan. right? So it's just like that. If you just have the, I mean, when we are just on the earth, to say where somebody is without a reference, you can't do it. But it's a coordinate system that you place on the earth. Then you can and you have a 0 point, some origin. Here you have an origin. Then with respect to that, you have 1, 2, 3 a scale going, 1, 2, 3 scale going, so perpendicular two scales. And from those two, you can pinpoint any location on this surface. So that's a spherical surface. Here our Cartesian coordinate system is a plane. So let's write this too. I mean, there's nothing new here. It's just that you're emphasizing or your knowledge that you already have in maybe in better words. Okay. So right under Cartesian coordinate system, a plane is a flat surface. A plane is a flat surface that goes on forever in all directions of the plane. That goes on forever in all directions of the plane. Now, why I included that line is because when you draw your coordinate system, you draw only a part of it, right? It is an infinitely large plane. You're drawing part of it. You can't draw the whole thing. Even when you draw a line, like y equals 2x plus 3 line is an infinitely long line, but you're just drawing part of it. You can't draw the whole thing. It's infinitely long. It goes on forever. Okay. So when you say line, it's infinitely long. When you say a plane, it's infinitely large. So keep that in mind. That's why I have put that sentence for you. Let me minimize this. If we were to place a point on a plane, if we were to place a point on a plane, if we were to place a point on a plane, coordinate geometry gives us a way, coordinate geometry gives us a way to exactly describe its location. Coordinate geometry gives us a way to exactly describe its location by the use of a pair of perpendicular axes. Write that in a different color. A pair of perpendicular axes. Within brackets, x-axis and y-axis. The plural of axis is axes. And that's how you pronounce it, okay? Axes. Within brackets, x-axis and y-axis, close bracket, that forms a grid. That forms a grid. This grid is the Cartesian coordinate system. So that's what is called the Cartesian coordinate system. It's a simple thing to do, but nobody thought of it until Rene Descartes thought of that, right? That by the placement of two perpendicular lines with a scale on it, that we can, we can give any point on that plane its exact location. So this grid is the Cartesian coordinate system. And again, there are two other names used for the Cartesian coordinate system. So we'll write that it is also called XY coordinate system or rectangular coordinate system. It is also called XY coordinate system or rectangular coordinate system. I want you to think about why those two names are there. XY coordinate system, we use the word XY coordinate system because it's formed with the axes are called X axis and Y axis. Excuse me, sorry. Right? So hence XY coordinate system. It's called rectangular coordinate system because when you have a point and when you say the coordinates of the point, it creates like a rectangle. Everything happens like rectangularly. Any point, when you give the coordinates of a point with respect to the origin, that forms a rectangle. The X distance and the Y distance, it comes as always a rectangle. So we call it rectangular coordinate system. Then, I mean, you might have a question, are there any other coordinate systems different to XY? Like, can we locate, or can we say the location of a point on a plane using some different coordinates, not the X length and the Y length? Have you thought of that before? There is another different coordinate system. That means, let me just tell you, when you have a plane, like say you have the two axes, right? You can give the location of a point by saying how far you have to go in the X direction and how far you have to go in the Y direction to reach that point. So with the use of two numbers, so two information, right? You need at least, that's all you need. You don't need three pieces of information to specify the location of a point on a plane. So by giving the X distance from the origin and the Y distance from the origin to that point, it's like giving directions. Go this many steps to the plus and minus tells you whether to go left or right or up and down. And then you're saying how to go from the origin to that point. You can think of it like that. Can you think of a different way of specifying the location of a point on this grid without, not by using the X distance and Y distance, but by using maybe some other two different information? So this also, you know, was thought by another person, right? A human being. Somebody came up with this other, oh, we can do it this way. Can anyone think of that? Or do you know about another coordinate system? It's the same thing, but you use a different pair of numbers to specify the location of a point. Does anyone know something called polar coordinate system? Polar coordinate system, not polar Abdul. Polar coordinate system. In polar coordinate system, the two information you give is, you say from the positive x-axis, you say an angle to turn, and then in that direction how far to go. So it's an angle and a length, two information. Say for example, if I say 30 degrees, 5 means to reach this particular point, I'm specifying by these two information. To go there, I have to first, if I'm at the origin, facing positive x-axis, I turn 30 degrees, and then I walk in that direction 5 units along a line. That's where my point is. So by the specification of an angle and a distance, also you can reach a point. So that's called polar coordinate system. That's the difference between rectangular and polar. Anyway, that's just additional knowledge for you. Then can you quickly sketch, draw this? Oh, so the point where the two axes cross is called the origin. And when you place these two axes, it divides your plane into 4 sections, right? We call them quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. In the first quadrant, all points have positive coordinates. In the second quadrant, X coordinates are negative, Y coordinates are positive. In the third quadrant, both coordinates are negative. In the fourth quadrant, X is positive and Y is negative. So just make a note of that too, okay? And quickly draw that and drop done when you're done on the chat box. Okay, so Masha is done. I will wait for one more person to be done, and then I will proceed. Okay, looks like if you're not done, please let me know. I'm going to go on to the next topic. So now we know what the Cartesian coordinate. Okay, Senithu has a question. Do we specifically have to take the quadrant labeled one as one at all times? You mean, yes, it's a convention, right? It's a convention. This is the first quadrant. You go anti-clockwise. First, second, third, fourth. It's a convention. Otherwise, I mean, if people as they want, if they label, let's call this first and this second, it's a standard. Yeah. So if I say this a certain point is on the first quadrant, you have to know where it is. So we have all come to the agreement of labeling the quadrants in this way. First is this, second is this, third is this, fourth is this. So for example, it's the third quadrant in which all the points have both coordinates negative. Okay, Sanitha, right? Okay, so now we know what the coordinate system is. Now let's start talking about geometrical objects. So we start with the atomic geometric object, which is the point. So if you have a point in this grid, or it's actually when you have a point, you place a grid on this, and then you can talk about this point. You can talk about things if you have 2 points, you can talk about how far the 2 points from each other. What's the midpoint of these 2 points? Like you can compute these things with the use of this coordinate system. So it's the coordinate system that allows you to do all these things. Okay, with the geometrical object. So we start with the first geometrical object, point. But before that, we write. So these are the things that we are going to learn. We learn about points. Then the next level would be lines, straight lines, and then certain curves. Now, when you say curve, I mean, so many different curves you can think of, right? So we learn about parabolas and circles in particular, but we also learn about certain type of curves, how to draw a certain type of curve. So we'll see what they are. So basically, this is what we will be learning in this section in P1. Okay, so we will learn about various aspects of points, straight lines, and curves with respect to this XY coordinate system. You write that, and then you write that first. Please do ask questions. Any question that comes to your mind, anything that is not clear, or anything like what Senithu asked. Actually, that's a good question, Senithu. Whether do we always take it in that order? Yes, we do. Okay, I hope you're done with this. So then your next topic, 2.2, let's look at points in space. So it's 2-dimensional. Now, when I say space, it's on a plane we are talking about. We're sticking to planes, right? So 2.2 points. So again, nothing new here. We're just writing this for the sake of having a complete note. And then also, I want to kind of strengthen you might know this, but I'm sure the way we are talking about it now would strengthen that knowledge that you already had. Okay, so a point on a plane with this coordinate system we can specify by an ordered pair of numbers. Ordered pair. Why do we use the word ordered? It's not, you can't give it in any order. It's the x coordinate comma y coordinate. It has an order. First x, then y. So it's called an ordered pair of numbers. Using the, I've abbreviated CCS, means Cartesian coordinate system. You also can do that, okay? This is too long to write all the time. So a point on a plane can be specified by an ordered pair of numbers using the Cartesian coordinate system. They are called the coordinates of the point. And then you again just quickly draw a little grid and show some points on different quadrants. So I have random. You can do it randomly. You don't have to do the exact points I have done. And I have also taken a point that is not exactly on, on the intersection of two grid lines. So you can have any, like, your coordinates can be ugly numbers, not exactly integers, right? So I have 2, 3, minus 3, 1. I also have shown 0, 0, that is the origin. And I have minus 1.5, minus 2.5. Now these two numbers can be any real number. It can be irrational. One of my coordinates could have been pi, could have been root 2, right? They can be any bizarre looking numbers, because these two lines are two real numbers, two real number lines. Let me know when you're done. So as I said, can you see that by when you show the location of a point using this pair of numbers, for example, 2, 3, that creates a rectangle. So all points, the two numbers, it creates kind of a rectangle, and the two numbers tell you the length and the width of that rectangle, isn't it? So the two numbers that you are using to specify the location of the point, the two numbers are the length and the width of the rectangle that you are creating. So that's a hidden information. The two points are also their lengths. You can say it's the width and the height of the rectangle, width and the height. Let me know when you're done. Okay, Umasha is done. Shall we move on? Okay, Tenami. Right. Now let's see. So that's how we give the, now, okay. Now you have to appreciate here. Okay. Now I want you to see the connection between, this is coordinate geometry. It connects geometry with algebra. That's what I said, right? A point is like a visual thing. It's a picture kind of thing, right? A point. It's something that you like. It's like a drawing. A point. But now that point has a we specify the point, or we identify the point with a pair of numbers. So if I just tell you 2, 3, like here, 2, 3, I'm talking about numbers, 2, 3, two numbers. But I'm talking about a point there. By specifying two numbers, I'm talking about a point. So with numbers, that's something that comes from algebra, and numbers is part of algebra. With the use of numbers, I'm specifying an object, a point. Okay. So that you have, I mean, if that doesn't like, I know it's not like an aha moment for you, because you are so used to seeing this. So the magic of it is gone for you now. Like, but for mathematicians, when you look at the history of mathematics, it was a huge thing for them. Wow, a point. Now we can talk about a point by using two numbers, right? And then now let's think of what things we can do now that we are calling a point with two numbers. Like if we have given it a name, 2, 3 is the name of that point right there at 2, 3. Then if you for example, if you think of the green point and the red point on my sketch, I can compute certain things because I have given them these number identification, right? Things like I can calculate the distance between those 2 points. Do you see how we can do that? Or I can also, for example, if I connect those 2 points with a line, I can talk about how slanty that line is. I can do a little computation with numbers, and I can talk about the slope of that line. Or when I have those 2 points, I can exactly tell you where the midpoint of I can compute the midpoint of that little line connecting the 2 points. So there are so many things I can calculate like that because I have given the points these 2 number identifications, right? Oh, so Akitmi, power cut, connection problems, I had to leave the meeting. Oh, okay. You had to leave the meeting, so that means you are connected back. You left and you connected back now. There are power cuts going on, isn't it? Even in mornings. Yeah, so at the end, okay, Akitmi. So at the end of the session, you please let me know in the group to send you the recording, okay? If you miss any part due to a power drop or a connection drop, it's just a matter of asking me for the recording and you catch that up, okay? Right, so under points, now what we are going to do is, we are going to learn some calculations that we can do when we know the coordinates of 2 points on a plane. So write that sentence and I will show you how to calculate certain things like the distance between them, like the midpoint between them, like the slope of the line connecting them and things like that. So we will learn, write that sentence, we will learn some calculations that we can do we will learn some calculations that we can do when we know the coordinates of 2 points on a plane. We will learn some calculations that we can do when we know the coordinates of 2 points on a plane. So things to do with 2 points. So different things that we can calculate associated with 2 points, we will see. Okay. So the first thing is, I will go to the writing pad now. You put a subtopic. I will try the writing pad. It looks to me like it's not focused like the, oh, now you can't say this. Give me a moment. Let me see whether I can fix this. Give me a moment. I will take you back to this, and I have to see whether, okay, it's working now. So I will take you to that. On my screen, it looks like this document pad is a little blur today. You let me know. Do you see the document pad now? It looks a little blur. It is a little blur today, isn't it? Is it a little blur? Now, if I write something, see whether it is clear to you. Oh, and it's too much of, let me off that. If I write, so a subtopic here, distance between 2 points. Distance, is that clear, or it's between 2 points? Is that okay, or is it, I feel like there is a little blur effect. It's clear? Okay, Umasha, thank you. Okay. Then is it my glasses? Okay. Okay. Distance between 2 points. Let's quickly, oops. Sorry. It's too much of, it's windy here. There's my underline that I'm looking for my ruler. Distance between 2 points. Okay. So let's think of 2 points. I'm going to just draw the first quadrant of my grid, X and Y, right? Suppose I have 2 points. I'm going to mark 2 points. Say I have a point A here and a point B here. Say my coordinates of my point A are, I'll say x1, y1. A bit blurry, right? Yeah, it's like a mist, like a dusty effect. Maybe I have pressed something. So I will not waste time to figure that out now. Since you can manage, we will continue. Yeah, okay. So suppose the coordinates, so I'm taking 2 general points. We will do an example later, specific example. So this is a general thing. So I'm going to call my point A coordinates as x1, y1. x1, y1. Because it could be any point. It will be x1, y1. And the point B could be any other point. Let me call it x2, y2. Right? Now, I can calculate the distance between these 2 points. Let me draw a line to connect them so that I can see the length of that line. If I want to find the distance between these 2 points, I can easily do that because I have the coordinates of the 2 points. Using the coordinates of the 2 points, I can calculate, not measure, right? Now, if I didn't have a grid and if I just draw a line, you might have to measure. I mean, that's if I have drawn it to scale, you can measure and get the length. But here, this can be a sketch. And if you know the coordinates of the 2 points, you can calculate the length of this line, piece of line. That is the distance between the 2 points, okay? And this is, wipe the screen. Senista says wipe the screen. Oh, maybe wipe the camera. Actually, yeah, so I will have to look for a tissue. I do have a tissue here, but I'll tell you, let's just do it, okay? If I try to do that, if this get messed up more, I don't want that to happen. Thank you for the suggestion, Senny. So I'm sure it might be something like that. Now, if you think like mathematicians, you can come up with how, because this is all to do with like basic little things. Can you think how we can calculate the length of this line? All you have to do is create a little triangle here. Let me do it with my pencil. If you think of a little triangle, you can create a right angle triangle here. When you have any 2 points, you can always create a right angle triangle. And then, what is this length? I'm doing this in pencil, okay? What is this length and what is this length? Do you see what these 2 lengths are? This length, for example, is the difference between, because, okay, let me not say it. Can someone tell me what that length is? From the origin, this is 0, 0, right? This is 0, 0. From the origin all the way up to here, the length is x2. This is x2. From the origin, the length up to here is x1. This is x1. Do you see what that length is then? x2 minus x1. x2 minus x1. x2 minus x1 is this length. What is this length? Similarly, y1 minus y2, y1 minus y2, y1 minus y2. Now you have to see that if I change the positioning of the 2 points, your x1, y2, where y2 goes, where x1, that might change. It could be y1 minus y2 or y2 minus y1, depending on who is higher. And whether it is x2 minus x1 or x1 minus x2 would depend on where exactly the 2 points are. That is okay. But it's going to be the difference between the y coordinates here and the difference between the x coordinates in a certain order. Then you can use Pythagoras theorem to calculate the distance. So this gives us a formula. So this is a standard formula to find the distance between, if I call this distance d, this is called the distance formula, famously known as distance formula, okay? I can write a formula for d. It is this is just simple Pythagoras theorem. Square root of this plus square of this, right? Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. So I can say, let me put here, now I'm going to show you, I'm going to just write x1 minus x2 square plus y1 minus y, without caring about which order x1 and x1, x2, y1, y2 must be. I just took x1 minus x2, y1 minus y2. Tell me why it wouldn't matter, even if you change it, because you are squaring it. You just need the difference and you square it. So it doesn't matter in what order you put these 2. That's a good thing to observe here. Do you all see that? Because now take two numbers, 5 and 7. 5 minus 7 squared, 7 minus 5 squared. Do you not get the same answer when you square it? Because all we need is the difference between 7 and 5. So it doesn't matter in which order you take it. 7 minus 5 square is 2 square, that is 4. 5 minus 7 square is square of minus 2, that is still 4. So this order doesn't matter. So you can be worry free about which comes first. It doesn't matter which comes first. Okay. So this is called the formula. This is the distance formula. I mean, you shouldn't even waste part of your memory to memorize this. It's just Pythagoras theorem. So copy this. Everything that I have written in pencil, you also can copy. And if you have highlighters, highlight this. This is how you compute the distance between 2 points when you have the coordinates. We'll do one example. Now, if you don't see the Pythagoras theorem connection and all that, this looks like a terrible, horrible, monstrous looking formula. If you just try to memorize it like a formula, square root of, and then x1 minus x2 square. I mean, but if you see the idea, it's not monstrous anymore. Because the idea is simple. It's just Pythagoras theorem. It's the square of this, square of that, and square root, sum and square root. But when you write it, lot of things there. But the idea behind it is very simple. And plus, these all formulas are given to you in the formula sheet anyway. Okay. While you copy that, let me move it slightly like that. The small example to apply. I will not even give you a diagram. I will just say, find the distance between the point A, coordinates -2, 3, and B, 4, -1. Oops. Find the distance between the point A and B. You don't have to sketch this on a grid, okay? You just compute it. Square root of square of the difference between x coordinates plus square of the difference between y coordinates. And the order in which you put the x coordinates or the y coordinates does not matter. If you get an irrational answer, leave it in surd form. Right, so you would get, you can say distance denoted with d -2 - 4 square So I took this minus this plus 3 minus minus 1 square. Be very careful. I will put a little bracket to this also. There I took. So I took minus 2, 4, and then I took 3 minus 1. So 3 minus 1, and I have the minus sign in between. Minus 2, 4. Right? What do we get? Minus 2 minus 4 is minus 6 square plus this is 3 minus minus 1, that is 3 plus 1, that is 4 square. Right? That is 6 square is minus 6 square is 36 plus 4 square is 16. That is square root of 52. Yeah, square root of 52, and that is a surd. That's not the square root of a perfect square, so it's going to be a surd. And can we simplify it? Can we write as a product of two numbers where one number is a perfect square? We can write 4 times something. But if you leave like that also, it's enough. Okay. So units, you can, let's say units, whatever units. It's a distance. It's simply, if anyone wants to see how it can be simplified, 52 can be written as 4 times 13. Then that is root 4 times root 13. That is 2 root 13 units. So the most simplified answer would be that, 2 root 13 units. So a bit of surds knowledge coming in here in your simplification. So unsimplified answer here, that would be correct, but it's not simplified, but that's the correct answer still. This is the simplified answer. Okay. Hope it is clear to everyone. Let's go to the next thing that we can calculate when you have 2 points. So this was distance between 2 points, right? This is distance between 2 points. Next, let's look at a topic parallel to this. We are still under points. This is distance between 2 points. Your next topic is parallel to that. The coordinates of, can you see? Okay. The coordinates of the midpoint of 2 points. Midpoint of 2 points. The coordinates of midpoint of 2 points. Right? Again, so let me draw a little grid. I'm sticking to the first quadrant, it's easy to work. But all these formulas are valid for anywhere on the grid, okay? And this time, let me take a point somewhere here, point A, and a point somewhere here, point B. So let me, again, two general points. General could be any 2 points. So I'm using symbols, not specific numbers. Let me call the coordinates of A, x1, y1. And the coordinates of B, x2, y2. And this time I'm going to see whether I can come up with a formula to find the coordinates of the midpoint between AB. That means if I again connect AB with a line, where exactly is the midpoint? This becomes useful in certain calculations, because the midpoint is something that we might want to compute, right? Midpoint. Let me call it M for mid. Now, can you think like mathematicians? In terms of these two, the pairs of pairs of coordinates of the 2 points, can I work out the coordinates of the midpoint? It's right in the middle. Very easy logic here. Because this point, if you think in horizontal units, A is x1 away from this point, right? From the origin. Find length and divide by 2. Find length and divide by 2. If you find the length AB and divide by 2, Senithu, you are going to get the length up to the midpoint. Length of BM or will be the same as length of AM. So midpoint, these two sections are equal in length. I don't want the length, I want the coordinates of M. What are the coordinates? Coordinates of M. Who can think? Coordinates of M. M coordinates. I will use 3 lines. Usually you can write the like a pair of coordinates. What, comma, what? This is coordinates. Who can think about that? I will help you, okay? So this is 0, 0, right? Again, up to here, now I want the length up to M for the x coordinate. X coordinate means how far M is from 0, 0. I want this length, right? This length up to here is x1. Up to here is x2. If I subtract the 2, okay. Oh, you have already done this in O levels. Yes. Do you see why that works? If you add the 2 x coordinates and divide by 2, you exactly get the midpoint. And when you add the y coordinates and divide by 2, you get the y. Yeah, you already know this. Okay. So it's x1 plus x2 divided by 2 is the x coordinate of M. Y1 plus Y2 divided by 2, it's like the average of the 2 numbers. That would be the midpoint of the 2 numbers. That's how you find the average of 2 numbers. You add and divide by 2. That would come in the middle. So that's the logic behind it, right? Average of the x coordinates, average of the y coordinates, or the coordinates of the midpoint. Okay, so you write that and then put a box around it and highlight it. These are the coordinates of M. It's not a length, coordinates. triple line coordinates. Or you can just write M and open brackets. Those are the two standard ways of writing coordinates of a point. You write the point, the label of the point, and then just open brackets and write the two numbers. Just like, I've written here, without the line also you can write it, without the 3 lines. And let's do a little example. So I hope you have copied it. Let me make this a little small. No. Example. Find the coordinates of the midpoint of the points A -3, 2 and B 7, -6. So something like this is called a formula. For the distance, what we had was a formula. True that they are now this is not an equation. The earlier one, it's like an equation, but it's a formula. A formula is something that is formula. These I mean, it's a word that we use in our day-to-day life also, right? Not outside of math, because it's something that you use to. It tells you how to do something. It's not something that you solve and find an answer for X. So reserve the word equation for equations that you solve. A formula is, you don't solve it, you use a formula to compute something. A formula tells you how to compute something. For example, the formula to find the area of a circle, A equals pi r squared. It's a formula. So these are formulas. Okay. What's the midpoint of A and B? You add the two x coordinates, -3 plus 7 divide by 2. Add the two y coordinates, 2 plus -6 is 2. I write 2 plus -6 divided by 2. That is 4 divided by 2 minus 4 divided by 2. You get 2, -2. Coordinates of the midpoint of the point A and B. If there is anything that is not clear, please let me know. And let me know when you're done copying. We will go to the next little computation that we can do when we have coordinates of 2 points. So we are discussing what things can we find when we have coordinates of 2 points. Done. Okay, Masha is done. One more person. Okay, Akitmi. Right. Let's go to do you hear me? Okay, I was gone, right, for a few seconds? Or did you hear me throughout? Because on my screen, it looked, it kind of got stuck. Okay, anyway, you can see and hear me, right? So the third topic, so the two things we learned so far about things that we can do with two points, how to find the distance between the 2 points, how to find the midpoint, the coordinates of the midpoint of 2 points, right? Third thing that we can calculate when you have the coordinates of 2 points is the slope of the line connecting 2 points, okay? So let's write the third topic parallel to the 2 topics you wrote before. Let me minimize this. Slope, or a better word would be gradient. Is it two? All right, okay. Gradient. It becomes too bright suddenly. Gradient of the line joining 2 points. Again, you already know this, how to find the slope or the gradient of the line joining 2 points. So if I start with two random points again, if I start with 2 random points, let me put 1 point here. Let me call it x1, y1. And another point here. Let me call it x2, y2. And what if I want to find the slope of the line connecting A and B? The slope of the line connecting A and B. Right? Slope of, I'll say line AB. Slope of line AB. The standard notation for slope is M. M for gradient, M for slope. So I can say M, simple M, and I can say AB here to say slope of what? Slope of AB, line AB, line joining AB is, you already know this, it's the y difference over x difference. So again, order doesn't matter, but you have to have the same order for both y and x. So if you do y1 minus y2, then it should be x1 minus x2 here. So this is, you have seen this, worked with this so much, nothing new. So quickly copy that. That's how you find the gradient of a line segment when you know 2 points. Y difference over x difference. Rice over run, in other words. I hope you have heard of that. Rice over run. For a horizontal line, for a horizontal run, how much you have to rice. So it's the ratio between the y, a y difference over x difference, that gives you the slope. Copy. I'll give a simple example again. Find the gradient of the line joining the points A, -2, 5, and B, 3, -8. Find the gradient of the line joining the points A and B. Okay, so you can write, so learn this notation. Gradient is denoted with simple m, and when you want to specify the line, I can say AB. AB means the line AB, the line connecting AB. Gradient of line AB. This is the symbol for that little phrase. Gradient of line AB is denoted with the symbol M, AB. Subscript AB is equal to y difference. So let me take 5 minus -8 over same order -2. Sorry about that. -2 -2 -3. That is 5 plus 8, 13 over -2 -3 is -5. That is minus 2.6. Minus 2.6. Okay. So it's a line like that, negative gradient, slanted this way. Okay. Clear now? This is all very, very simple so far, but these basics have to be really solid. Okay, no confusion, no question. All should be very clear. Okay. Then, so 3 things we discussed about things that we can do with 2 points: the distance between the 2 points, the coordinates of the midpoint of the 2 points, and the slope of the line connecting the 2 points. Okay. Then, since we are on the topic of little gradient here, let's quickly have another little subtopic. This is something additional that you have to know. I'm going to put it. Oops! I'm going to put it here itself. a parallel and perpendicular line segment. Again, you know this, but just to have this thing clear, complete, parallel and perpendicular line segments or lines. Okay, I'll say line segments. Could be just line. Now, what's the difference between a line and a line segment? Line, if I just say line, it's an infinitely long line. A line is just a line means it's infinitely long. Line segment means part of like connecting 2 points. It's a segment of a line. Okay, so I'm talking about what you can say about the gradient of lines that are parallel and that are perpendicular. Could be lines or line segments. So I'll say line segments. Again, you already know this. So we can quickly copy. Parallel and perpendicular line segments. If you have, I will do this side by side. I dropped my pen. So I will do it side by side. Then you have so draw with me. Say segments that are perpendicular, like this. That are perpendicular, right? If the gradient of this line is m1, if this is m1, gradient is m1, and the gradient here is m2, and if you know that they are parallel, what can you say about m1 and m2? Two line segments that are parallel, what can you say about m1 and m2? If two lines are parallel, what can you say about their slopes? Hurry up. Someone? Are the same, slopes are the same. So what can you say about m1 and m2? They must be equal. Parallel means same slope, right? Same slope, same gradient. So if parallel, m1 must equal m2. If the gradient of this is 2, for example, this must also be gradient 2, right? Gradient, remember, is denoted with a number. It's a number. You quantify the idea of slope. You represent it with a number. The greater the number, the slopier, the slanter, the steeper your line is. So if parallel lines, same gradient. If you have perpendicular lines, say this is m1 and this is m2, and they are perpendicular, what can you say about m1 and m2? Senitu, did you write anything? I just see a blank space. If lines are perpendicular, their slopes multiply into -1. If you multiply them, you have to get -1 as the answer. Still, I see just a blank. Maybe something wrong with my Zoom chat box. I see like just spaces. The product of the slopes of perpendicular lines, if I do m1 times M2, it's -1. There is another way of saying this in words. Their slopes are, the slope of one should be the negative reciprocal of the other one. Okay, let me write that in words. M1 must be the negative reciprocal. Negative, that is a different way of saying this. Okay, negative reciprocal of M2. Of M2. M1 is the negative reciprocal of M2. What does that mean? If M1 is 3, M2 is turn 3 upside down and change the sign, negative. So if M1 is 3, M2 must be -1/3, negative and reciprocal. If M1 is -half, what's M2? If they're perpendicular. If M1 is -half, M2 is turn it upside down and change the signs, 2. That's correct, Senator. Now I see you're 2. Okay, so that's what you have to know about the gradient of parallel lines and perpendicular lines. Okay, if lines are perpendicular, their slopes multiply into -1, or another way of thinking about that is one slope must be the negative reciprocal of the other, right? Negative reciprocal of the other. Okay, so that is all for about points, right? The next 2.3 topic is straight lines. Straight lines, and we have about 10 minutes. Let's go back to this, and let's just begin this, right? Do you have any questions from what we did so far? Because we are going into the next topic in coordinate geometry. We talked about points and things that we can calculate with when we know the coordinates of 2 points. Any questions from that? If not, let's write the next topic, leave a few lines and put your next topic parallel to the way you wrote points. That was 2.2. Now let's look at straight lines placed in your grid. Okay, lines. In math, if you just say line, it's understood that it's a straight line. Line means straight. Okay, lines are straight. So you can even just say lines in the context of math. Lines mean straight lines. Okay, right. Let's quickly talk about it. Now again, so in geometry, you can just have a line, just a line, like you can have a line like that. It could be just a line lying in space. But when you have your grid, when you look at this line relative to your Cartesian coordinate system, then this line starts to have an identity. Just like a point was given a pair of coordinates, a name, a label, an identity, you can give any line an identity when it is placed in a coordinate system. A line is identified by what? A point is identified by a pair of numbers that we call its coordinates. A line is identified by an equation. An equation. If I place a coordinate system here, like that, right? Now, relative to that coordinate system, I can talk about the equation of this line. So I can exactly identify this line with an equation. It has a certain slope, it has a certain positioning that can be captured by where it is cutting the y-axis. Using these little information, you can create an equation for this line. Okay. Now, you have to also know, we say the equation of the line, equation of the line. What do you mean by the equation of the line? What does that equation tell you? What does it give you? All that you have to know. Okay. But mainly, basically, in coordinate geometry, we represent a line with an equation. So again, I want you to appreciate here. Now let me go to a different page. If I write an equation, look at this equation. This is like, it looks like algebra. Here's an equation, sorry. Here's an equation. Y equals 2x. This is an equation connecting two unknowns, y and x, like two variables. Y equals 2x plus 3. So do you see a shape here? Is this anything geometrical, or is this an equation, something in algebra? This is something in algebra. It's an equation. This is an equation, right? I am in the world of algebra. Y equals 2x plus 3 is something that I see in algebra. But this represents a line, something in the geometry world. This represents a line. So this is the connection between geometry and, I want you to always appreciate that. When we are in coordinate geometry, we are combining geometry and algebra. Geometrical objects are given algebraic things. This is an equation, right? So here, this for example, this equation might have the equation y equals 2x plus 1, maybe, right? Okay, so let's write that. So that's what happens. So this is how we combine. Oops. Looks like I got a bit stuck here. All right. Let's go back to this and write our little note under. Straight lines. A straight line on a plane. A straight line on a plane. A straight line on a plane can be specified by an equation. Equation in a different color. In points, a point on a plane can be specified by an ordered pair of numbers. Here, a line, remember, a line is made out of a lot of points. This is the next level of points. Points were the atoms of geometric objects. A lot of points can be put together to form a line or even a curve. We are talking about a line first, right? And then when you have this line, that can be identified by an equation that relates the, oh, do you see the x here? Or is it gone? Oops. Again, so there is something, oops.